So to continue on from our last set of videos, the next thing that needs to happen if you are starting kind of from raw data that's been recorded is you need to have these labels inserted in here, and they're not normally in there. And so because this data already has those labels in there, it's hard to kind of start from scratch and illustrate how to do this. But I will go into the theory behind it. The simple step is to say analysis, impedance cardiography, DZ/DT classifier. And I'm not going to click on that now, but what that's going to do is it's going to ask me, go find somewhere in this bottom channel, this derivative of the impedance signal channel, a representative cycle. And so more important than doing that is for me to explain what a representative cycle looks like. These all look like nice representative cycles. So I'm going to zoom in a little bit, but not quite that much. About here, I'm going to hide these other two channels. Although actually having the ECG channel in there is quite helpful as well. So a typical shape is there's this large spike, that is your C point of the impedance, the PEP, the impedance channel. The B point is kind of the biggest thing, the most important thing that needs to be there. It typically should be at this exact place where the slope changes most dramatically from being it might be past where it changes from downward to upward. And these aren't labeled exactly as I would perhaps have them ideally. Right here is a good example. There's a little, I don't know, a notch there where the slope is steep, but then it changes from somewhat steep to extremely steep. That's typically where I would have put the B point. But we have different algorithms we can use to place the B point there, and they're simply following the algorithm, and it doesn't always wind up being exactly at that spot. The algorithm I have found that I've been using puts it as close to that spot as I have seen. I've tried different algorithms and they have less success. They might put the B point way over here. So this is the algorithm I have here is as close as it gets. So there should be this characteristic up spike on most of them, but it isn't always perfect. This is just kind of almost a straight upslope from the last kind of trough that preceded this large C spike here. So your B typically goes somewhere in that transition from slightly upward slope to a very steeply upward slope. The C point is the peak. The X is typically the next trough following the C peak. So we can see that here. And the O point is the peak, the largest peak after the X point and before the next cardiac cycle begins, before you see your next B, C, X, O. So this O is this peak that follows the X typically. Occasionally a Y is in there. It's like a sometimes Y thing, sort of like your vowels. The Y, if it's there, it's going to be the next peak immediately following the X trough. And in this case, it kind of found two peaks, so it was able to add a Y label in there. And then this following peak is the O point is that last peak before the next cardiac cycle kicks in. So what you're looking for, and unfortunately when you're first trying to find a representative cycle, you don't have the benefit of these labels in there. What your next step would be to actually acknowledge where a representative cycle is, and then acknowledge is going to be putting those labels in there to the best of its ability. You'll be using the ECG up here to kind of inform what you're doing. Sometimes the O points can get very tall, and they might make you wonder, is that really an O point, or is that supposed to be another C point? Your guide is to look up to the ECG signal, and you can see you're clearly squarely in between cardiac cycles. So that O point isn't like a second cardiac cycle. You can see it very clearly. And since the ECG is more impervious to noise, that's going to be your ongoing guide as to where these cardiac cycles are really falling. So what your step is going to be is to find something that looks very representative with this notch and with the peak and with a nice slope following, etc., and not somewhere where there's a whole lot of noise. And you're going to be highlighting that representative cycle. And I'll illustrate that on another video. But that's going to be your next step, following kind of eyeballing your raw data and getting zoomed into a place that looks fairly representative.